Hello Year 9s, how are you guys? Welcome back to Mr. Chen's videos. So today in math, we will be continuing with geometry and we will be looking at similarity, which involve enlarging and reducing. Okay, uh, in math, these two terms means something else compared to what you know your regular English term. So we will look at it here. So uh, first I have to remind you that enlarging or reducing a shape is not equal to your isometric transformation. Okay, so let's have a look here. So as you know, isometric transformation, which is over here, the blacks it's been circled with black color, which involves rotation, reflection, and translation. Okay, and translation is this one. Okay, it means moving your triangle, congruent triangle, up or down or to the left hand side or the right hand side. It's just translation, so pretty much just like translocation, so you just move them around, which is still the same thing. Reflection is pretty much a mirror in between of the two congruent triangle. uh, they are still the same side and angle. Remember all those angle, side angle side, angle side, and hypotenuse length. Okay, all those please refer back to the previous videos. You have learned those in year 8. You should be. If you haven't, you might have to revisit that again. Okay, and your rotation is pretty much just look at this for isometric transformation. Isometric transformation. Rotation is pretty much you have a point and then you just rotate it around, okay, or you can go the other way. Enlarging or reducing, the topic that we're going to talk about today is different. It has the same proportion but different size. So your a triangle or a figure, okay, you can enlarge it or reducing it. It still has the same proportion, but it just has a different size. Uh, this is what we call similarity. Uh, in English, I know similarity means the same, like similar to, let's say, uh, my your brother would like your two siblings will look similar, or two twins will look similar. In this case, similar means you have to meet two conditions, which is stated here below. I'm gonna use so the two conditions that you have to follow. Okay, in order for you to have two similar shape, is the matching sides are in the same ratio and matching angles are equal. I'm going to explain that right now. So if you look at here, there are multiple parallelograms. They are similar figures. The only thing different is their size. Okay, so this is the original. This is the original parallelogram. If you reduce the size, the K here means the factor, scale factor. Okay, so if scale factor is bigger than 1, the figure is enlarged. So what that means is, if the K is 2, that means each of these sides will be twice as big. I'm gonna give you a few examples. So let's say this is 5, 3, 7, and another make it 6. Okay, so if the figure is greater than 1, the figure is enlarged. So let's say if this has a, just for example, if this has a scale factor of 2, okay, what that means is this similar parallelogram is twice as big as the original. So it will be, let's say if these are all in centimeters, this will be 6 centimeters, that will be 12 centimeters, and that will be a double, which is 14 centimeters, and that will be 10 centimeters. You know what I mean? It means each of the matching side will have the same ratio, which is twice as big because it has a scale factor of 2. If it has a scale factor of 3, that means everything needs to be triple the length. Okay, each matching side. On the other hand, if the scale factor is less than 1, that means the thing is smaller. Okay, so if it is 0.5, let's say this scale factor is 0.5, which means everything is 50% of the original size. Okay, because it is half. So that will become 1.5 centimeters. That will be 3 centimeters. That length, that matching side will be 3.5 centimeters. And that matching side will be 2.5 centimeters. Okay? So, and if the K is 1, okay, K is 1, it means it is the original size. Because it didn't get enlarged, it is not enlarged, or is not, and it is not reduced. So that means everything, if it is 1 equal to 1, everything will remain the same. Okay, everything will remain the same. So just make sure you are clear with this point, because if you are clear, you should be able to know how big it has been enlarged or how small it has been reduced. Okay, and remember, to have a similar shape, you have to match, you have to have these two conditions met. You have to meet these two conditions, which is matching side are the same ratio, which I have demonstrated over here, and matching angles are equal. Okay, so for example, you know this parallelogram all add up to 360 degrees. So if this one has to match that one, okay, it doesn't matter if the size is reduced, the angle will always be the same. Okay, the angle, let's even, like for example in the triangle, it doesn't matter whether it has been enlarged by twice, the total internal of a triangle, and in order to be a congruent thing, to be a similar shape, you just have to make sure all of them will add up to 180. Triangle will always be 180 degree internally, and obviously to be a similar figure, similar triangle, the matching angles should always be the same. So let's say three of them will be 60, 60, 60. The other one which has been enlarged or which has been reduced will all be 60, 60, 60 as well. Okay, so that will be it for these videos. So these videos kind of introduce you what what the similarities is, and which includes enlarging and reducing. And remember, they are not isometric transformation. They are similarity, which is enlarging or reducing. Okay. Uh, isometric transformation only produce congruent shape. Okay, enlarging does not produce congruent shape because it has been enlarged or reduced. Alright, thanks for watching these videos. Please write down notes and ask me questions during lessons or leave the comments below. And good job guys. Have a good one. Peace out. Bye.